Hey everyone, this is Pratirth and welcome to my course, Getting Started with Artificial Intelligence for Business. By the time you'll be watching this course, everyone and their pets will be talking about, or at the very least, heard the term artificial intelligence. Now, there are plenty of misconceptions and narratives, both true and false, around AI. Is it something you can build a business around? Or, if you already have a business, is AI a magic pill that can solve every issue with it and put you on track to becoming a billionaire? In this course, you'll gain a firm understanding of what AI is, the tech used in the industry today, and the endless possibilities and some huge challenges of putting AI to work in your business. This course is divided into 3 modules, and each module is carefully designed to answer a crucial question. First, we'll answer the question, what exactly is artificial intelligence? Don't worry, it won't be a series of boring definitions. We'll look through some examples of AI in our daily lives and things like the different types of AI. Next, we'll see what makes up modern AI. This is where you learn about those terms that you've all seen thrown about nonchalantly like big data and machine learning. Finally, we'll answer the most important question of them all. What role does AI play in the world of business? We've gotten a bird's eye view of the course. Now, time to get more specific. What will we learn in this particular module? We'll start off the module by looking through examples of AI and then consolidating our understanding with the definition of what artificial intelligence is. AI is a huge term that encompasses a lot of things. So next up, we learn about the different types of AI, both based on the technology used and based on their functionality. We'll wrap this module up with a brief history of AI that's sure to get your juices flowing for the upcoming modules. Let's get started. Let's start right at the beginning. What exactly is artificial intelligence or AI? But before we understand the definition of AI, let's look at where you might have seen or experienced AI in your daily lives. One of the most popular consumer applications of AI are virtual assistants. From Alexa, Google, Siri, and Bixby, they're everywhere. On your phones, your cars, and your homes. Each interaction with these assistants provides them with an opportunity to learn more about your voice and accent, thereby providing you a secondary human interaction experience. Virtual assistants use deep learning to know more about their subjects, ranging from your dine-out preferences to your favorite songs. Something else that has been gaining in popularity are smart or robot vacuums. Vacuum tech has greatly improved over time. Gone are the days of struggling with a flimsy, unwieldy hose and a bulky container on wheels the size of a small island. Now, you can effortlessly keep your home free of dust, pet and human hair, and other knickknacks and debris with the help of a robot vacuum without ever leaving the comfort of your couch. Here is something that is all the rage these days: self-driving cars. AI is the force that is bringing autonomous driving to life. Terabytes of data is fed into the system to build a model, to train the machines to learn, and then test the results in a safe environment. Data from cameras, sensors, and geomapping is helping create succinct and sophisticated models to navigate through traffic, identify paths, signage, pedestrian-only routes, and real-time elements like traffic volume and road blockages. A simple search will show you the sheer number of companies working on this: Tesla, Uber, Google, Voyage, and a lot of others. Entertainment and streaming services. Wimbledon, the holy grail of tennis tournaments, in 2018 used IBM Watson to analyze player emotions and expressions through hundreds of hours of footage to auto-generate highlights for telecast. This saved them a ton of effort and cost. Thanks to deep learning, which is a subset of AI, they were able to factor in audience response and match or player popularity to come up with a more accurate model. Netflix and Amazon are enhancing their deep learning capabilities to provide a personalized experience to its viewers by creating their personas, factoring in show preferences, time of access, history, etc., to recommend shows that a particular viewer will like. Given everything you know now, let's construct a definition of artificial intelligence that is easy to remember. In the simplest terms, artificial intelligence refers to systems or machines that mimic human intelligence and capabilities and can iteratively improve themselves based on the information they collect. When you think about it, every example we've given can be grouped under this particular definition. Let's have a brief look at the major milestones along the timeline of AI, from its birth right up to the state of the art, or at least whatever is known publicly. We start in 1950 with the Turing test. Alan Turing, an English mathematician, published Computing Machinery and Intelligence, in which he proposed a test to determine if a machine has the ability to exhibit human behavior. This test is famously known as the Turing test. The Turing test is a deceptively simple method of determining whether a machine can demonstrate human intelligence. If a machine can engage in a conversation with a human without being detected as a machine, it has demonstrated human intelligence. In 1956, the first artificial intelligence program, named Logic Theorist, was constructed by Alan Newell and Herbert Simon. This program verified 38 of 52 mathematical theorems, as well as discovering new and more elegant proofs for several of them. In the same year, the word artificial intelligence was first adopted by John McCarthy, an American scientist at the Dartmouth Conference, and was coined for the first time as an academic field. In 1966, Joseph Weizenbaum created the first ever chatbot named Eliza, which engaged in conversations with humans. The 1970s and the early 80s were a period famously known as the first AI winter. A lot of scientists could not pursue or continue their research to the best extent as they fell short of funding from the government and the interest towards AI gradually declined. 1997 saw the first instance of a computer beating a human. IBM's computer, the IBM Deep Blue, defeated the then world chess champion Garry Kasparov and became the first computer to beat a world chess champion. In 2011, Apple launched Siri, a voice-controlled personal assistant built into its latest iPhones. After this, 2012 saw the launch of Google Now, and 2014 witnessed the launch of Alexa, which was Amazon's answer to Apple and Google's personal assistants. 2016 saw Hanson Robotics create the first robot citizen, Sophia, a humanoid robot capable of facial recognition, verbal conversation, and facial emotion. In 2022, we saw the latest iteration of DALL-E 2, which is a new AI system that can create incredibly realistic images and art from a description in natural language. You can register online for the service and try it out yourself. It truly is incredible. So what have we learned in this module? We've learned that AI refers to systems or machines that mimic human intelligence and capabilities to perform different tasks, and can iteratively improve themselves based on the information they collect. The types of AI are split based on two things: functionality and technology. Under technology, you have things like narrow AI, general AI, and super AI. Whereas under functionality, you have systems like reactive machines, limited memory, theory of mind, and self-aware. We also saw different applications of AI that we might have encountered in our daily lives, such as virtual assistants like Siri, Google Now, Alexa, etc., smart vacuums, streaming services, and self-driving cars. That's it for this module. Coming up next, we'll dive a little deeper into the world of AI, and we'll look at the contents and components of modern AI. See you there. Last on our list in the current module, but natural language processing is a field into which tons of resources and research are being thrown at. Let's look at what it is in more detail. Let's say you're in a restaurant in a foreign country. The menu seems to be entirely in the local language. You pull out your phone, open up an app like Google Translate, scan the menu, and out pops the version translated to your language. This is something I've encountered many times. And that right there is natural language processing at work. So what exactly is natural language processing? NLP, or natural language processing, is a branch of AI that allows computers to understand, analyze, and interpret text and spoken word in the same way human beings can. NLP enables computers to understand natural language as humans do. Whether the language is written or spoken, natural language processing uses artificial intelligence to take real-world input, process it, and make sense of it in a way a computer can understand. So how does it work? NLP has two main phases: data pre-processing and algorithm development. Data pre-processing involves preparing and cleaning text data for machines to be able to analyze it. Pre-processing puts data in workable form and highlights features in the text that an algorithm can work with. Let's look at some of the ways that this is done. First is tokenization. This is when text is broken down into smaller units. Tokenization can separate sentences, words, characters, or subwords. When we split the text into sentences, we call it sentence tokenization. For words, we call it word tokenization. This is the first step in any NLP pipeline. Then, we have stop word removal. This is when common words such as a, the, how, from, etc. are removed from text, so unique words that offer the most information about the text remain in place. Then we have lemmatization and stemming. This is when words are reduced to their root forms to process. And finally, we have part of speech tagging. This is when words are marked based on part of speech they are, such as nouns, verbs, and adjectives. Once the data has been pre-processed, an algorithm is developed to process it. There are many different natural language processing algorithms, but two main types are commonly used. One is a rule-based system. Rule-based systems rely on handcrafted grammatical rules that need to be created by experts in linguistics or knowledge engineers. This was the earliest approach to crafting NLP algorithms, and it's still used today. Then, we have machine learning-based system. Machine learning algorithms use statistical methods. They learn to perform tasks based on training data they are fed and adjust their methods as more data is processed. Using a combination of machine learning, deep learning, and neural networks, natural language processing algorithms hone their own rules through repeated processing and learning. Let's look at a simple example of text classification using machine learning. We have some text in a document, and we also have a tag associated with that text to indicate whether the text is positive, negative, or neutral. We run it through a feature extractor, which gives us the features which are then fed into a machine learning model along with the tags. This part of the system is called training. And then we have the train model. Now, when we have more text data, you can extract the features and then feed it into the already trained model, and that will tell you if the text is positive, negative, or neutral. This part is called the prediction. All of the theory looks very nice, but what are some of the real-world applications of NLP? Analyzing customer feedback. NLP has become an essential business tool for uncovering hidden data insights from social media channels. Sentiment analysis can analyze language used in social media posts, responses, reviews, and more to extract attitudes and emotions in response to products, promotions, and events. Information companies can use in product designs, advertising campaigns, and more. Virtual assistants or chatbots. We've talked about how virtual assistants that live on your phone or TV help you out in your daily lives. While they work with voice mainly, chatbots perform the same function with typed text queries. The top-of-the-line stuff also learn to recognize contextual clues about human requests and use them to provide even better responses or options over time. Spam detection. You may not think of spam detection as an NLP solution, but the best spam detection technologies use NLP's text classification capabilities to scan emails by language that often indicate spam or phishing. These indicators can include overuse of financial terms, characteristic bad grammar, threatening language, inappropriate urgency, misspelled company names, and more. Why is NLP important? Businesses these days use massive quantities of text-heavy, unstructured data and need a way to efficiently process it. This is where NLP is useful. We finally come to the end of this module. I know I've hit you with a lot of information. Let's look at the highlights. First, we had a look at big data. Big data refers to extremely large datasets that cannot be analyzed using traditional methods. Without big data, AI would not exist. Then, we talked about how machine learning is a subset of AI that contains techniques that enable machines to learn with experience. It can be broadly divided into three categories: supervised learning, unsupervised learning, and reinforcement learning. We then moved on to deep learning, which is a subset of machine learning based on neural networks that permit a machine to train itself to perform a task. We saw the importance of forwards and back propagation in deep learning. Finally, we looked at NLP or natural language processing, which is a branch of AI that helps computers to understand and analyze human language. Up next, in the final module of the course, we'll take a look at the effects of AI in the world of business. See you then. Now that we've talked about big data, let's talk about something that every single one of you would have heard about in some form or the other. What is machine learning? Every single major branch that we'll talk about in this module is a subset of artificial intelligence. AI is a very broad general term in that it includes any technique that enables computers to mimic human intelligence. Machine learning, on the other hand, is a subset of artificial intelligence, which includes techniques that enable machines to improve at tasks with experience. It gives computers the capability to learn without being hard-coded or explicitly programmed. So how exactly does machine learning work? The entirety of machine learning revolves around different types of algorithms and techniques. The machine learning process starts with the input of training data into a machine learning algorithm. Of course, the type of training data that is being input does impact the algorithm, and that will be covered in the next clip. Now, whenever input is provided to a machine learning algorithm, it returns a result value or predictions based on the model. If the prediction is accurate, it is accepted and the algorithm is deployed. But if the prediction is not accurate, the algorithm is trained repeatedly until acceptable results are reached. This enables the machine learning algorithm to continually learn on its own and produce the optimal answer, gradually increasing in accuracy over time. Machine learning is something that is fairly involved and complex, and hence it's been broadly divided into three categories. Let's see what they are. The three categories are supervised learning, unsupervised learning, and reinforcement learning. Now, these differ based on multiple things like the data being fed, the way the algorithm processes the information, etc. Let's talk about each of them in a little more detail. Supervised learning is the most popular paradigm for machine learning. It is the easiest to understand and the simplest to implement. Given data in the form of examples with labels, we can feed a learning algorithm these example label pairs one by one, allowing the algorithm to predict the label for each example and giving it feedback as to whether it predicted the right answer or not. Let's see a simple example. Here, you can see that we have a bunch of labeled data. We have 3 types of fruits, and each of these fruits are labeled apple, banana, and cherry. This is training data that is fed into the model on which the model is trained. Here, the model by itself tries to learn what makes a banana be labeled as such, or an apple labeled as an apple, etc. Once the model is trained, you can show the model some test data. For example, here we're showing the model a picture of a banana, but we're not telling the model that it is a banana. If the model is trained well, it will output the prediction as banana. Supervised learning is itself divided into 2 sections, classification and regression. It is a classification problem when the output variable, or the thing you have to predict, is a category, such as the apple or banana problem we just saw, and sunshine or rain, etc. It is a regression problem when the output variable is a real value, such as dollars or weight, or even how much inventory you need to stock in your warehouse. Next up is unsupervised learning. Unsupervised learning is very much the opposite of supervised learning. It features no labels. Instead, our algorithm would be fed a lot of data and given the tools to understand the properties of the data. From there, it can learn to group, cluster, and organize the data in a way that a human can come in and make sense of the newly organized data. Here, you can see the same set of data being fed into the model, but this time we provide it with no labels. The model then discovers similarities and patterns in the data using various techniques and then groups them accordingly. At no point does the system know the correct output with certainty. Instead, it draws inferences from datasets as to what the output should be. So the basic difference between a supervised model and unsupervised model is this. Supervised learning models are trained using labeled data, while unsupervised learning models are trained using unlabeled data. Reinforcement learning is fairly different when compared to supervised and unsupervised learning. Where we can easily see the relationship between supervised and unsupervised, the relationship to reinforcement learning is a bit murkier. Reinforcement learning can be looked at as the model learning from its mistakes. The following diagram will show the typical framing of a reinforcement learning scenario. An agent takes actions in an environment, which is interpreted into a reward and a representation of the state, which are fed back into the agent. Place a reinforcement learning algorithm into any environment and it'll make a lot of mistakes in the beginning. So long as we provide some sort of signal to the algorithm that associates good behaviors with a positive signal and bad behaviors with a negative one, we can reinforce our algorithm to prefer good behaviors over bad ones. Over time, our learning algorithm learns to make less mistakes than it used to. Next up on the docket is deep learning. Again, this is a term that you probably would have heard about a lot as well. What is deep learning? You remember this diagram, right? In this, we saw how machine learning is a branch of AI. Deep learning is a branch of machine learning that uses artificial neural networks to help computers understand and process information in a way that mimics how humans learn. Think of a neural network as a big network of interconnected brain cells called nodes. These nodes work together to analyze and make sense of data. In the past, creating really complex neural networks was difficult because computers were not powerful enough. But today, with the help of big data analytics and more powerful computing resources, we can build much bigger, more complex neural networks. And the cool thing is, these neural networks can learn and make decisions faster than humans in some cases. Reiterating that final point, this is the worldwide Google Trends data on the term deep learning. You can see it generated next to no interest for a decade post-2004. But at this point, around the end of 2014, it started taking off very quickly. There are multiple reasons for this. A possible reason could be that deep learning requires large amounts of data, and the devices that collected data by the buckets weren't as prominent as they are now in the early part of the millennium. The technique also required lots of computational power. And again, computational power and storage capacity became much cheaper as we approached 2020. We know that deep learning uses different, more complex techniques. But why would we prefer it over traditional machine learning? Performance is one of the big reasons. If we plot an amount of data versus performance graph, deep learning's line would look something like this. And this is what traditional machine learning would look like. As you can see, it plateaus after a certain level of performance and data. Keep in mind though that this is a rough graph, but the gist of it will still hold. Another major difference between deep learning and machine learning is how feature extraction is done. Feature extraction basically means identifying the variables that will help the algorithm predict better. In machine learning, most of the applied features need to be identified by an expert and then hard-coded as for the domain and data type. Example features can be pixel values, textures, shape, position, and orientation. The performance of most of the machine learning algorithms depends on how accurately the features are identified and extracted. Deep learning algorithms try to learn high-level features from data itself without the need for an expert. This is a very distinctive part of deep learning and a major step ahead of traditional machine learning. Therefore, deep learning reduces the task of developing a new feature extractor for every problem. Keep in mind though, deep learning is not a silver bullet, meaning it definitely is not the best solution for any and all situations. The main downside is that it is significantly more complex and therefore will require more processing time. This will be a no-go in case you require instant feedback. You do need to carefully analyze the problem and requirements of your application before you embark on a solution technique. We've seen what deep learning is, but how exactly does it work though? If you want to know how deep learning works, the first term you need to familiarize yourself with is neural network. Now, what is a neural network? A neural network is a system of interconnected nodes that aims to mimic how the human brain processes information and recognizes patterns. When we go through the design and working of a neural network, you'll quickly see why that is an accurate, if simple, description. This is the structure of a typical, fairly simple artificial neural network. Don't worry if it looks complex. I'm going to keep the explanation as simple as possible. Here, each circular node represents an artificial neuron. Neurons in deep learning models are nodes through which data and computations flow. Each arrow represents the connection from the output of one artificial neuron to the input of another. There are three types of layers in a neural network: input layer, hidden layer, and an output layer. A combination of these artificial neurons make up a layer of the network. After pre-processing and cleaning the raw dataset, it is first sent to the input layer. The data then moves through to the hidden layer, which is the brain of the neural network. The number of hidden layers in a neural network determines the complexity of the problem the network can solve. This particular network, as you can see, has two hidden layers. The data then finally moves through to the output layer, which gives us the required outputs. Each of these connections you see also contain a number known as a weight. In the end, what the neural network does through calculated trial and error is to determine the value of these weights. The ability of the network to determine the weights accurately will determine how well it performs. Let's see how all of these components mesh and work together. The first part is called forward propagation. In this step, as you can see from the arrow below the diagram, information flows from the input layer to the output layer. Here's how it works. Firstly, The weights mentioned earlier are randomly initialized. The data, which is now at the input layer in numerical form, is then multiplied with the weights. The multiplied values are then passed to the hidden layer. Keep in mind that the input layer has multiple nodes, and each node there is connected to each node in the hidden layer. A quick glance at the diagram on your left should help you solidify this step. At this point, each node in the hidden layer sums up the values given to it and passes it through something known as an activation function. Activation function adds nonlinearity to the network and essentially decides which of these neurons fire. It determines the output of the hidden layer. The second or any subsequent hidden layers do the same thing. The output of the hidden layer multiplied by the weights again becomes the input to the final output layer, which then applies further functions to determine the output. If it is a binary classification, meaning if the network has to decide between two choices, there will only be one output node. But if it is a multi-class problem, there will be multiple output nodes. We now move on to the second and final stage, backpropagation. Here, information flows from the output layer all the way back to the input. Since we are training our network, and this being a supervised learning technique, means we already know what the output is. So in the first step of backpropagation, the network compares the predicted output to the actual output. Since this is the first time we are performing these steps, the predicted output will invariably be different from the actual output. Based on how far off the network is from the actual output, or in other words, based on its error, the network adjusts the weights. If you look at the bigger picture, adjusting the weights will determine what input the network considers important in helping it solve the problem at hand. A connection given a lower weight is considered unimportant and vice versa. This step is performed using the chain rule in differential calculus. Now, forward propagation and backpropagation is performed multiple times, and each time the network keeps adjusting its weights until finally the network is able to solve the problem with acceptable accuracy. That, in a nutshell, is how a neural network works. It probably might be a good idea to watch this video one more time because it is very important for a conceptual understanding of what goes on behind the scenes in deep learning. In the previous module, we saw what AI is, and we looked at some of the things that use it that you would have encountered in your daily life. We then traveled across more than 6 decades of AI history. In this module, we'll take a look at modern AI. What are the things and terminologies you need to know if you got started today? First, we'll take a look at what big data is and why it is important to AI. Then, we'll talk about what machine learning is and the different types of machine learning. In the next section, we'll delve further into the AI ocean and learn about deep learning and the things that make it tick. Finally, we'll talk about the technique which helps computers understand human language, natural language processing. One of the first things you need to know while talking about modern AI is big data. What is big data? And why is it so important to the advancement of AI? So, what is big data? Big data refers to extremely large datasets that generally cannot be processed or analyzed by traditional computing programs. For data to be considered big data, there has to be a large amount of it coming from multiple sources and with a high rate of collection. Summarizing that last sentence, we could say there are 3 V's to big data: volume, variety, and velocity. If the definition didn't clarify things for you, let's look at some examples of big data. Black box or flight data recorder. This is the data generated by airplanes, including jets and helicopters. Black box data includes flight crew voices, microphone recordings, and aircraft performance information. A single jet can generate about 10 plus terabytes of data in 30 minutes of flight time. Then we have the stock exchange data, meaning data from stock exchanges about the share selling and buying decisions made by customers. The New York Stock Exchange is an example of big data that generates about 1 terabyte of new trade data per day. Then, we have the Internet of Things, or IoT. A connection to the Internet enables companies to collect data through devices like smart home systems, robotic vacuum cleaners, smart TVs, mobile devices, and wearable fitness trackers that log files. We've seen what big data is, but why is it so important to AI? Big data and AI go hand in hand. Without data, there would be no artificial intelligence. Without artificial intelligence, all that raw data wouldn't be usable, as there would be no way to process it efficiently, let alone in real time. AI has become much more powerful over the last decade. Thanks to the amount of data being collected, combined with improved algorithms, artificial intelligence has become more helpful and precise, allowing data analysts to process even more data that can be used for business success. Big data has allowed the field of AI to advance more quickly. The need to analyze large datasets has created practical applications for artificial intelligence and nearly unlimited data for the technology to process. According to Forbes, the most recent research indicates that a combination of AI and big data can automate nearly 80% of all physical work, 70% of data processing work, and 64% of data collection tasks. This suggests that the two concepts have the potential to tremendously affect the workplace, in addition to their contributions to marketing and business efforts.